So for a function of a random variable, the expected value of a function of a random variable is not equal to the function of that expectation. However, there are counter examples as well. So there are some functions where this is equal to other one. For example, linear functions. If you remember the end of the chapter 4 again, if g is a linear function, my friends, expected value of ax plus b was equal to a times expected value of x plus b. So for linear functions, this may be true. But for other functions, this may not be true. Okay? So in most of the cases, it says this is not equal to true, but there are some exceptions like linear functions where this is true. Okay? Now, how about the variance? In most of the cases, again, the variance of gx is not equal to g of variance x. And a proving example is, again, the variance of ax plus b. Remember, it is not equal to a variance x plus b. What was the variance of ax plus b? If you remember, again, the end of chapter 4, the variance of ax plus b is equal to a square variance of x. So we take the multiplier outside the variance as squared after squaring it, and b does not affect anything in the variance. Okay, it vanishes. So the distribution of g of x is also different. So for example, when you say x is an exponential random variable and g is a function, when you transform this exponential random variable, you may get a totally different function. Okay, a totally different random variable. So the function of that random variable may not be exponentially distributed. Okay, so we need to identify the expectation and the variance and the distribution of a function of a random variable. And unfortunately, you cannot simply use these stupid equations. Okay, they are not true. It is not equal. Okay, so they are not equal, definitely.